So again, there's California, there's the tribes, there's Arizona, and Hawaii, but we haven't had many people from Hawaii. But there's one other little state, Nevada, and so we're lucky enough to have Marianne Denton come over. She's done it 2 years in a row, and she's going to keep doing it. I like to, in this beginning, the agenda set up to kind of hear some program information from the various entities. And so Marianne's going to come up. Some people might remember Karen Vargas, who was involved with with Nevada for a long time. And you saw all the people that were mentioned, and not everyone was mentioned that's involved with bioassessment in California. But in Nevada, there's one. And the couple of people that work for her. So Marianne Denton's the #1 person in bioassessment in Nevada, and she gives a good presentation. She's going to come up and brief us on what that little old state's doing.
Great, my name is Marianne Denton. I am the Bioassessment Coordinator for the state of Nevada, and I'm very, very honored to be here to speak with you today, so thank you. And I'd like to talk a little bit about the title of my talk, Every Day is an Adventure. Every year I hire these great interns, and they're so enthusiastic and eager to do everything perfectly. But as you know, when you're out in the field, there's no such thing as perfectly, right? So you roll out of your tent at 6 in the morning and the truck tire's flat. Or you throw the YSI in the stream, the batteries go dead and you don't have replacements. And my interns, they get so frustrated because it's not going perfectly. And I go, well, every day's an adventure. And they're like, what? I'm like, every day's an adventure. We run into a rattlesnake, we work around it. We've had a shotgun pulled on us. We had to work that out. But we But we worked together to get some great bioassessments done. So I was very, very proud that on the last day of field season, I went out to my dusty, trusty field truck, and they had written this in the back window, every day is an adventure. And I promise you, every day is an adventure. So given that, I'd also like to thank my interns from this past year. A great group of young stream ecologists. I'm looking forward to the day that they are the teacher, I am the student. My colleague, Zach Blumberg, who is here today, he assists me in the bioassessment program, and he's a really nice counterbalance to my frantic, frenzied field work, so it's good to have him. EPA Region 9 for all of their support for the Nevada Bioassessment Program. And Jim, thank you for this meeting. I am so excited about today's agenda and the entire meeting. And thank you to all the other scientists and folks that I meet here. You return my emails, you take my calls, and it's really useful for me because, like Jim says, it's me, we've got Dan, but I don't have a lot of, especially in my department, a lot of internal feedback. So when I get feedback from you, it's very, very useful. And I apologize if I don't always take your advice, but it does mean a lot to me. So to give you a little rough idea about what I'm going to talk about today, our field season that we had, a couple of streams that we're going to talk about, and what's next up until I come to see you again next year. So every field season adventure. But these are not the faces of adventure, right? They're pretty cranky, and they're cranky at me, and let me tell you why. So on Monday, June 23rd, I said, be at the office at 7 in the morning. We're going to drive 5.5 hours to Elko, and we're going to drive another hour and a half south of Elko, and there's a small stream out there. It's probably dry. If it's not dry, we'll get it done. And if it is dry, I've got to back up an hour away. 12-hour day, no big deal. Typical field day. 14 hours later, no assessments done. They were not feeling the spirit of adventure. The next day, on Tuesday morning, I said, okay, be in the parking lot at 6. The site that we have to go to is very remote. It's in the Jarbidge Wilderness, but we'll get out there. We're going to have a great day. Okay, a great day turned into spending the majority of it trying to get to the site. We had two successful recons. I got us lost on the back roads of the wilderness, and so that was about a 14, 15-hour day, and the spirit of adventure was not in my intern's hearts, not at all. We had 10 sites that we needed to do for the National Rivers and Streams Assessment. We visited 17 sites in an effort to get those done. We were only able to complete 6. A lot of the sites were dry. We did have one site that had an illegal marijuana grow, and something that you're very familiar with. And the landowner said, well, we don't want you to come out right now. I'm like, this is when you want me to come out. I need to come out now. And then for the Nevada Systemic Program, I had more flexibility in choosing my sites. I like to get at least 30 to 50 done per year. We were only able to get 26 done. And then we had 10 dry sites. So here we are on the mighty Humboldt River. It's about 15 miles east of Winnemucca. And you can tell by the wetted width of this river, it's going to be a long day, right? And so it's deep and it's swift. And again, the wetted width is really, really wide. And one of my rules is as soon as you see lightning or hear thunder, you're out of the river. So there's a lot of thunder clouds up in the sky. June 18th, when this picture was taken, only got half the assessment done. Go out 5 weeks later, same exact spot. So I know this is what you're seeing in California too. We just couldn't finish that site, and so that's what we were facing in Nevada. And I want to take all responsibility for the drought conditions. I started in the bioassessment field in 2012, my first field season. As you can see, severe drought started in May, moving to extreme drought. We had one dry site that year. 2013, again, the drought all throughout Nevada, extreme drought to exceptional drought. We had 16 dry sites that year. And this year, that red stain of drought on these maps just went all the way across Nevada, another 16 dry sites, so very challenging. And so I do take responsibility for the drought, but I'm not leaving bioassessment, so we're gonna have to get some snow or rain or something. Okay, I'd like to talk about 3 sites today, comparison. And these 3 sites, they are all on the California border. This image is a little dark. But you can see Mono Lake. This would be kind of the central Manhattan region. 2 sites are in Nevada proper, 1 site's just over the California border. And these 3 sites have been sampled 3 times using EMAP type protocols. And the sites more closely, this is my aggregated ecoregion of Eastern Sierra, so essentially from the tree line down west or east into the Great Basin. So the first creek I'll talk about is Chautauqua Creek. It is designed as a reference site by ORD over a decade ago, and it is fully supporting for all the beneficial uses in the 303D list. It's in the White Mountains, and it has no connectivity to any other water body. The second stream is Rough Creek. It's in the Bodie Hills, so it has a high influence of historic mining drainage. It is impaired for 3 beneficial uses. And Sweetwater Creek, just right on the other side of the California border. It is considered a reference site from early bioassessments by best professional judgment, but it is impaired for 2 beneficial uses on our 303D list, and that's in the Sweetwater Mountains, and it's a tributary to the East Walker. So again, these sites have been sampled 3 times using EMAP type protocols, so some of the characteristics. Nice mountain streams, high elevation. Sweetwater Creek's about 2,500 meters. Here at Davis, we're 15 meters above sea level. Second order streams hop right over them, nice canopy coverage. And Chautauqua Creek in the blue and Sweetwater Creek in the green have a more similar slope, where Rough Creek in the orange is a low gradient stream. The channel morphology, Chautauqua Creek and Rough Creek are very dominated by the riffle glide, where Sweetwater Creek is at the top of the watershed, a lot of cascades, rapids, riffles, and no glides. And very little human influence on these streams at Chautauqua and Rough Creek. There's range, grazing. One time, Zach and I were out in Rough Creek and had to share the creek with a big a big bowl, and that was the time we decided to call that stream. And there is a road about 40 meters from the stream bank at both Rough and Sweetwater Creek, but not a lot of human influences on these sites. So I figured they were good sites for comparison. So to talk about the indicators I'm talking about, a couple years ago I came and talked about integrating indicators to one value of ecological integrity, so I'm still kicking that around. So the first one I'd like to talk about is substrate. I've heard it talk about here as a stressor, and this is something that we can incorporate as a metric into indicators. And I'm looking at percent fines and sands, percent embeddedness. For Periphyton, I'm using the Kentucky Diatom Bioassessment Index, and the reason I am using that is that the Desert Research Institute in Reno, Nevada investigated metrics on the Truckee River for an IDI, and they investigated all of the metrics in the Kentucky DBI. And I'm not an algal ecologist, so I'm just working with what's easy for me and what I can integrate. And for the Benthics, we're using the Predictive Model Condition Index developed by Utah State. I'm not using the ODE, and I will explain that further when I get to that section, so just using MMI. So substrate. Habitat complexity increases biodiversity. We know that the bugs we love, like cobbles and little niches and stuff like that. But in Nevada, sedimentation is the most pervasive form of pollution on streams, and associated with land use. So we have a lot of mining, a lot of agriculture, and so as that sedimentation in the stream is going to increase, you're going to lose light penetration and affect primary productivity. You're going to fill up the interstitial spaces and lose habitat, and also, the fines may interfere with our little creatures' gills and stuff. And also, we have a lot of embeddedness that's going to change the roughness of the stream, maybe change the hydraulic processes of that stream. So I've taken all of my sites that have been bioassessed using the EMAP protocols, EMAP type protocols, for the eco region of the Sierra Nevadas, excuse me, and I'm going to compare percent fines and sands to the distribution of the MMI scores and the DBI scores. So on the vertical axis, the percent, and on the x-axis, the indices. So for those sites, you can see for the MMI, the mean of the reference sites is about 20% fines and sands. You're not going to get above 45%. And then for the impaired, pretty much the full range. And then for the DBI, this gives me a completely different story, which I haven't completely investigated yet. But if you look at the Diatom Bioassessment Index, the mean of the reference sites is higher than the mean of the impaired sites. So I think I need to look at that more closely, see if there's any correlation. And for my three sites, Jacobich Creek is about 36% fines and sands, greater than 75% embeddedness. Rough Creek, 44% fines and sands. Again, it's a low gradient stream. And Sweetwater Creek, high in the watershed, cascades, rapids. It's only about 6% fines and sands and about 50% embeddedness. So for Periphyton, again, I'm not an algal ecologist, but I'm really advocating people who are looking at water quality health to consider diatoms as an indicator, and Periphyton as an indicator, because I think it's a great way to look at impairment, causes of impairment, and also track restoration. I've had people go, how am I going to track my restoration? I said, the best and quickest way to track your restoration is look at your Periphyton communities. So again, here are all my sites for the Eastern Sierra Ecoregion, the distribution frequency of the scores. Of course, the mean is right about 1 for the reference sites, up to the first standard deviation, so those would be all reference sites. Likely disturbed and most disturbed. In those sites, we have 14 most disturbed sites in this aggregated ecoregion based on the DBI. And for my 3 streams, in the light pink color, that is the reference sites for the Eastern Sierra. Jacobich Creek, very tight around the reference mean. Rough Creek, around the reference mean as well. But Sweetwater Creek is far below the second standard deviation. So saying that that's definitely an impaired site. according to the DBI. And in terms of percent similarity, there's nothing really significant to see here. Obviously different streams. I like how Rough Creek is just right on top of each other for each of those communities. So for the Benthics, again, I'm not using the ODE for the Benthics, and that comes from Jake Vanderland at Utah State developed our ODE and our MMI under the direction of Chuck. And in Jake's thesis, and also in the paper he published to support his thesis, he says that the ODE for Nevada, compared to other regions like California, is relatively imprecise at predicting reference condition. And they attributed that to the spatial isolation of these sites in very arid landscapes. And so I like to be a little bit more conservative when I'm talking about reference condition, and so I am not using the ODE. They found that the MMI was significantly more accurate predicting reference condition in Nevada. So here again are my ecoregion sites, and mean, second standard deviations, and the reference condition for the MMI, I only have 15 sites that would be considered reference condition out of those 75 sites. When I run the ODE, I have same sites, same samples, I have 65 reference condition sites. So that's a pretty big difference. And again, I want to be more conservative, and so this is more evidence for me that the ODE is not particularly accurate predicting reference condition in Nevada. So for my 3 streams, again, in the Eastern Sierra, the reference sites right there around the mean, a reference, Chatovich Creek in the blue, pretty much reference, kind of getting down to maybe undetermined. Rough Creek hit reference once, but usually impaired. In Sweetwater Creek, again, below second standard deviation, an impaired site based on the MMI. And nothing significant in terms of percent similarity. One of the things that I find pretty interesting is you kind of have this crescent in terms of the sites, and the sampling in 2012 has another crescent. So maybe I'll look at that later. So, you know, that makes sense. Chatovich Creek, again, a reference site, a nice isolated site, fully supporting for its beneficial uses. A little sketchy on the MMI, but very reference on the DBI. Rough Creek, the biotic condition is reflective of the physical condition. In the Bodie Hills historic mining watershed, so it is very impaired, a lot of sedimentation. Impaired for the MMI, but reference for the DBI, and maybe the phosphorus there is facilitating the DBI. I'm not an algal ecologist, but that's something I would need to look at. But what's going on with Sweetwater Creek? Both for the DBI and the MMI, it was far below the second standard deviation, being impaired. It's a beautiful stream. There's no negative influences on it. So with the exception of total P, there are no stressors. It had very low overall numbers of diatoms, and specifically the symbilla richness is that water quality increases, then you have an increase of that taxa. And that was very low. I think it was actually pretty non-existent for these samples. So I thought, well, I'll try the BMI pollution tolerance. It's good to excellent. But there's no biodiversity in this stream. For these 3 samples, they were nearly completely sampled, so it wasn't like 30% subsampled, nearly completely sampled, and greater than 96% taxa for each sample. But there's no onates, there's no coleopterus, there's no little montane Pisidium clams, no snails. I looked at the channel to see if there was any natural barriers to migration. I couldn't find anything. And out of these 3 samples, just 1 leaky and 1 water mite. So it's perplexing. And I also looked at the 3 samplings that were done for targeted riffle, and the taxa tells the same story. It's just all insects, which we would normally say is great, right? But I also love biodiversity. So some streams are just some streams. Maybe this is just the natural condition of Sweetwater Creek. I looked at the chemistry, I've looked at other things. There was some historic mining on the top of the Sweetwater Mountains, but I don't know if it affected that watershed. And so I could beat my head against my desk and go, what is it with Sweetwater Creek? But maybe this is just the natural condition for this stream. I'm going to go with simplicity is better. For me, being sort of a solo bioassessment person, I'm going to use the indicators that work best for me. 2 years ago when I was talking about trying to incorporate riparian vegetation into an indicator. But Nevada's so diverse, the landscape's so diverse, it just doesn't work. Maybe it's better as looking at stressors rather than an indicator. And as we know, stressors can be elusive. They can mask one, have an additive effect. We could just chase things and do causal analysis until my boss says, Mary Ann, stop it. That's what I'll keep doing. So people know how much I love field season, and here I am in my temple of bioassessment, and they say, what do you do when it's not field season? So what I'd like to do this year is maybe work with the Tahoe Basin wildlife biologists and use bioassessment as a help that surveys. Of course, plan for the 2015 field season. We want a lot of snow, we want a lot of rain, we want more snow. Every Friday I get these emails and it says your research gave profile score is 3.7. I'm like, is this something I need to be worried about? Is this a professional thing for me? What do I need to do? And then I look at Eric's strengths. His is 31. And I'm like, right? But the thing is, Eric's got like a whole bunch of publications. So maybe what I need to do is publish this year. I need to get together a paper and publish that year, and I can, bump up that research profile score. Finalize the bioassessment programming documents, and continue to develop and integrate these assessment analysis. And one of the things when I talk to my bosses and I say, let's look at this, they go, we study flowing surface waters. But I really am advocating for episodic water body assessments, especially in years like this, and we don't know what the future holds. I think it's an important tool that we need to have. But most importantly, I'm going to develop an online reference digital thing that's to help increase my taxonomic skills, daydream about streams. So with that, we are very close to break, so we can go to break right now, or I'll try to answer some of your questions.
I noticed that,
No.
I noticed that you had very high canopy on your 3 streams, and I was wondering what that canopy consisted of.
Those are going to be, at the Sweetwater, it's going to be pretty much understory willows, things like that. Pretty much the same with Jacobage Creek. Rough Creek, you are going to have some taller cottonwoods, maybe a couple of pines, but we're not dealing with tall canopy greater than 5 meters. So more, we're crawling through these streams like they're tunnels. More questions? Are you serious? Everybody's anxious for break.
Well, no, they're not going to break. You're going to have to listen to me. Actually, I have a question.
Jim's got a question.
Are you able to get bioassessment in any program like TMDLs or NPDS permitting or stormwater or any of that stuff?
I am really advocating for that, Jim. I think that it's important that even if we don't use that in our regulatory standards, that's something that should be reported, and that's something that we do have somebody that handles those permits, but unfortunately there's no integration. And I think there should be. You come to cocktail hour with me tonight and you will hear my complaints about how I think that bioassessment should be more integrated into Nevada.
Yeah.
Oh.
We have a question here? Okay. They'll come to you if you don't.
got a minute or two. Let me just speak on behalf of Springs that was brought up by the gentleman back here in Desert Springs. You've got some great ones out in Nevada, or so I've heard. There's some really neat mollusks that live in those springs, spring snails.
68 endemic snails in Nevada that live in these springs, and Don Seda of the Desert Research Institute, I'm stealing your thunder, aren't I?
Please, please, please.
Don Seda of the Desert Research Institute does do a lot of spring assessments, but in Nevada, due to the spatial isolation of these streams and springs, we do have a lot of endemic mollusks, 68 endemic snails in these springs. Sometimes I'll find some endemic snails, not like I'm a big mollusk taxonomic person, but I love to find them, and so it is a great thing. And one of the things, as we know, that climate change occurs, and is anybody here from Las Vegas? Okay, good. I probably don't want this on the internet. Stop recording. As the Southern Nevada Water Authority wants to pull water out of the eastern Nevada, and there have been studies about, it's essentially groundwater mining. They're taking these 10,000-year aquifers and want to pipe it out of eastern Nevada by the Great Basin National Park, and studies have shown it's just going to dry these springs up. So springs are being studied in Nevada, but not by me.
Thank you. I mean, stop me if you want, but if...
Oh, I will. We'll see how far.
Yeah, thank you. I mean, I think that's really good. And I've been working with Don Seda for years. My name is Joseph Furnish. I work for the U.S. Forest Service, and just as an advocate for springs, if you want to protect biodiversity, fauna and flora, a lot of endemic fauna are there. I just found out the Sierra Nevada Conservancy paid for surveys on 124 sites within the Rim Fire and the Stanislaus National Forest. I just kind of stumbled over that because I happened to go to a meeting. But anyway, I'll bring up some other things later. Thank you. This is good stuff. And we need to coordinate these kinds of efforts and do these kinds of surveys. There's a lot of springs I can know nothing about. Nothing. Thanks.
Good, thank you, Joseph.
Any other? Oh, we've got one more question right over here.
Have you been able to make any impacts on the streams that you surveyed with the data and how they're managed? It's particularly with respect, I don't know how Nevada is, but with respect to diversions as you're changing the flows as climate change.
There are things I dream about and things that I believe are possible, and then there's the reality. So yes, I'd like to do that.
But so far, not no luck.
No, I mean, so I guess that's it for question. Oh, yep, one more. Here we go.
So I heard you said that you're not connected that well with the regulatory efforts within Nevada, but I was curious to see, because you're doing a lot of assessment and sedimentation and rangeland management, I was wondering if there is any connection that you've been able to make between rangeland management and sedimentation reduction, because you see that when you do
Our
substrate.
non-point source program will fund projects with ranchers and things like that. So even though I'm in our standards and monitoring program for the bioassessment, that data has not been looked at. And one of the things we have to be really cognizant of is that's Nevada, and we have to be, I don't love seeing a bowl in a stream, but cows not condos, right? We have to be really very sensitive to the economic realities in Nevada, which are mining and agriculture. All right, well, every day is an adventure. Don't forget that. If you don't think you can have an adventure today, you come talk to me. I will give you an adventure.
You mean tonight at the social?
Oh yeah, tonight is supposed to be a total adventure, but here we go.
Thank you, everyone.